A very good morning to all my dear students. Today we are going to discuss about our first chapter. Subtopic is logarithms. So let us recall law of exponents. Here, what is the relation between logarithms and exponents? Here both are inverse forms. Here exponential form and logarithm forms are inverse of one another. So let us take one example. 81 is equals to 3 power 4. 81 can be written as with the base 3 is 3 power 4. Here 3 is the base, 4 is the exponent or index. 4 is the exponent or index. This is the exponential form of 81 with the base 3. So 81 is the fourth power of base 3. So the relation between exponentials and logarithms. Let's take two examples. 2 power x is equals to 4. 3 power x is equals to 27. So here 2 power x is equals to 4. Also written as with base 2 is 2 square. Here bases are equal. Here bases are equal. Power should be also equal. So here x is equals to 2. Here x is equals to 2 is the result. Next example, 3 power x is equals to 27. So 3 power x is equals to 27 is also written with base 3 is 3 power 3. So 3 3s are 9, 9 3s are 27. Here is also bases are equal. Power should be also equal. Here x is equals to 3. In exponential form 2 power x is equals to 4. Here x is equals to 2. Here 3 power x is equals to 27. X is equals to 3. Next, let's take another example. If 2 power x is equals to 5, 3 power x is equals to 7. These are in the form of exponentials. So here we can't find by using exponential laws. So these type of examples we can't find with the help of exponential forms. In this situation, a new relation logarithm is introduced. So logarithms are always inverse forms of exponential forms. So this should be written in logarithms. Log 5 base 2 is equals to x. Log 5 base 2 is equals to x. Next one, 3 power x is equals to 7. This is exponential form. The logarithmic form of 3 power x is equals to 7 is log 7. The base 3 is equals to x. This is the logarithmic form of 3 power x is equals to 7. Here log 5 base 2 means 2 power some value gives us 5. Here is also log 7 base 3 means 3 power some value gives us 7. This type of powers values are always irrational numbers. So these are the fundamental laws of exponents. Here a comma b are real numbers. Here a is not equals to 0, b is also not equals to 0. So m comma n are integers. So our first law from exponents, a power m into a power n is equals to a power m plus n. A into b whole power m is equals to a power m into b power m. Next one, a by b whole power m is equals to a power m by b power m. So a power m whole power n is equals to a power m into n. Next one, something to the power of 0. Here a to the power of 0 is equals to 1. Next one, a power minus m is equals to 1 by a power minus m. These are the 6 types of laws related to exponents. These are the fundamental properties of logarithms. These are the fundamental properties of logarithms. First one is product rule. Next one, quotient rule. Third one, the power rule. Here in the product rule, log x into y is equals to log x plus log y with base a. Here log x into y is equals to log x plus log y with base a. So here in the quotient rule, log x by y is equals to log x minus log y with base a. In power rule, log x power n is equals to n into log x with base a. Here log x power n base a is equals to n into log x base a. Here power shifted in front of log. Here x power n is equals to n into log x with base a. So these are the laws of exponents. These are the laws of logarithms. Logarithms and exponents are always inverse to each other. Here 2 power x is equals to 5 is the exponential form. Log 5 base 2 is the logarithmic form. Both are inverse to each other. This is our first question from Do This. These problems related to this, all problems related to exponential forms. So first question, 4.73 whole to the power of 0. So our first question, 4.73 whole to the power of 0. So this is of the form a power 0. So result is 1. So this is of the form a power 0. A power 0 is equals to 1. So 4.73 whole to the power of 0 is also is equals to 1. Here a is equals to 4.73. Power of 0 is equals to 1. Something to the power of 0 is equals to 1. Next, fifth one, 0.25 whole to the power of minus 1. So a to the power of minus m is equals to 1 by a to the power of m. So that is equals to a to the power of minus m is equals to 1 by a to the power of m. So 0.25 whole to the power of minus 1 is equals to 1 by 0.25. So for two decimals, rationalize with 100. Multiply numerator and denominator with 100. So 100 by 25, result is 4. Remaining as your homework. Second Roman, express 10, 1000 in exponential form. So exponential form means a power n, right? 10 power 1. Exponential form of 10 is 10 power 1. So 1000 is 10 into 10 into 10 means 10 power 3. These are the exponential forms of 10 and 1000. Remaining as your homework. Next one, B-bit. Express in simplest exponential form. This is the question, 16 into 64. So here 16 is equals to 4 square into 64 means 4 cube. So that is equals to a power m into a power n. This is of the form a power m into a power n. Result is a power m plus n. Here is also a power m into a power n is equals to 4 power 2 plus 3. So that is equals to 4 power 5 is the result. Or Here we can also write this combinational with base 2. Here 16 means 2 power 4 into 64 means 2 power 6. So a power m into a power n. So here a power m into a power n is equals to a power m plus n. Here 2 power 4 plus 6. So that is equals to 2 power 10. 2 power 10. Remaining two problems as your homework. So this is our first question from Do This. Write the following in logarithmic form. So first question, 7 is equals to 2 power x. So 2 power x is equals to 7. Let's take log. Here base is 2. Log 7 base 2 is equals to x. This is the logarithmic form of exponent form. 7 is equals to 2 power x. This is the logarithmic form of exponent form. 7 is equals to 2 power x. Here 2 power x is equals to 7. 2 is the base. So log 7 base 2 is equals to x. This is third one. 1 by 81 is equals to 3 power c. Here 3 power c is equals to 1 by 81. So take log. Here base is 3. 1 by 81. Log 1 by 81 base 3 is equals to c. This is exponential form. This is logarithmic form. Here 3 is the base. 1 by 81 is the log value, is equals to c. This is method 2. 3 power c is equals to 1 by 3 power 4. 81 also written like this, 3 power 4. So that is equals to 3 power c is equals to, so 1 by a power n is equals to a power minus n. A power minus n means 3 power minus 4. So log base 3, 3 power minus 4 is equals to c. This is the result. This is our next question. Write the following in exponential form. So this is the logarithmic form. Log 25 base 5 is equals to 2. Log 25 base 5 is equals to 2. So here exponential form is 5 power 2 is equals to 25. 5 power 2 is equals to 25. This is the exponential form of log 25 base 5 is equals to 2. This is the exponential form. So next our question, next do this. Solve log 32 base 2 is equals to x. Log 32 base 2 is equals to x. So exponential form of log 32 base 2 is 2 power x is equals to 32. So that is equals to 2 power x is equals to 2 power 5. So bases are equal. Power should be also equal. So x is equals to 5 is the result. Here let first change it into exponential form. So here 2 power x is equals to 32. 32. Change is 32 into exponential form of base 2. Here 2 power 5. Bases are equal. Power should be also equal. So x is equals to 5 is the result. Remaining as your homework. Next question. Think and discuss. Does log 0 base 2 exist? Give reasons. So here log 0 base 2 is a undefined number. Why? Because we can never get a 0 by raising anything to the power anything else. Here let's take log 0 base 2 is equals to x. So 2 power x is equals to 0. So 2 power x is equals to 0. Here x is a undefined number. That's why log 0 base 2 is a undefined number. Here next question, prove log b base b is equals to 1. So let's take log b base b is equals to k. So here by the exponential form, b power base b power k is equals to b. Here b power k is equals to here b power 1. Here bases are equal, power should be also equal. So k is equals to 1. So this is the final result. This is the proof of log b base b is equals to 1. Here k is equals to 1. K is equals to 1. Next one, do this. Express the following as the sum of logarithm. So this is our first question from do this. 35 into 46. So take log 35 into 46. So this is of the form log x into y. Result is log x plus log y. So log 35 plus log 46. Log x into y is equals to log x plus log y. So this is the sum of logarithm. Next do this. Express the following as the difference of logarithms. So here this is our first question, 23 by 34. So this is of the form log x by y. So result is log x minus log y. So here log 23 by 34 is equals to log 23 minus log 34. This is the difference of logarithm. This is the difference form of logarithm. This is our next to do this. Using log x power n base a is equals to n log x base a. Expand the following. This is our first question. This is actually third rule, third property of logarithm. Log 7 to the power of 25 base 2. Here 7 power is 25. Here n is equals to 25. Our formula is log x power n is equals to n into log x. Here bases are a. Here is also n is 25. So n log x means 25 log 7 base 2. This is the final result. This is the expansion of log 7 power 25 base 2.